Hey guys, find the vertical asymptotes and horizontal asymptotes of this function. Or, if there aren't any, show why there aren't any. How do you find vertical asymptotes? Vertical asymptotes exist when the bottom of the function equals 0. In this case, that means negative x is negative 4, and pretty clearly, we have a vertical asymptote when x is 4. Done. That's your vertical asymptote. There's no more. Nothing else to say here. Horizontal asymptotes, however, are a little trickier. Horizontal asymptotes exist when the limit as x approaches positive infinity actually has some value that isn't infinity itself. And you can also have a horizontal asymptote in the other direction, the negative infinity direction. So we need to calculate what these two values are, because these two represent the horizontal asymptotes. Alright, let me get some paper out here. We're doing this for the square root of 3x squared plus x all over negative x plus 4. Alright, let's do the positive limit first, alright? The limit as x approaches infinity of this function. How do you calculate that? The way that I always did it was to multiply by, in this case, 1 over x over 1 over x. This always cancels out to 1, so you're allowed to do it. But it will also serve to get our exponents down and get rid of our constants, especially as x approaches infinity. Here's what I mean. This now equals the limit as x approaches infinity of 1 over x times the square root of 3x squared plus x all over 1 over x negative x plus 4. When I multiply that in, here's what happens. Can you see what I'm writing? No. Limit as x approaches infinity. Multiply 1 over x into the square root. You end up with 3x squared over x squared plus x over x squared. Notice the 1 over x became 1 over x squared when it went inside the square root, because that square root had to serve to cancel out something, and if it was 1 over x squared, when you take the square root of that, it ends up giving out this value in the end. And in this case, you end up with negative x over x plus 4 over x. Here's why this is significant. First of all, some of these exponents cancel. In this case, the limit as x approaches infinity of the square root of 3, see how the x squareds cancel each other out, plus 1 over x. X cancel with the square. All over negative 1, see the x is canceled? Crossed out with an x. Plus 4 over x. This is significant because as x approaches infinity, 1 over x tends towards 0, and 4 over x tends towards 0. So that means the limit itself is the cube root of 3 over negative 1, which is negative root 3. So the horizontal asymptote in the positive x direction is negative root 3. Pretty sweet. We are going to do the exact same thing, except for negative infinity now. Actually, we can do basically the same thing, can't we? No. Alright, limit as x approaches negative infinity of 3x squared plus x all over negative x plus 4. Again, multiply the top and bottom by 1 over x over 1 over x. You get the limit as x approaches negative infinity of 3x squared over x squared plus x over x squared all over negative x over x plus 4 over x. Oh, that's the same so far. But let's take a look at what happens. The limit, can you see that? As x approaches negative infinity the square root of 3 plus 1 over x over negative 1 plus 4 over x. As x approaches negative infinity, this turns out to be 1 over a negative number. So this is 3 minus 0, but that doesn't matter. And this turns out to be negative 1 minus 0, and that doesn't matter. So I'm getting that it's the square root of negative root 3 on this side as well. Let me just check my solutions, because I don't remember getting that the last time I did it. Oh well. Apparently it's negative root 3, and we do have a horizontal asymptote in that direction as well. Hey, best of luck to you in your endeavors.